Please tell me whether I am audible and visible or not. Okay. Please tell me whether I am audible and visible or not. Audible? Okay. Bharat Kumar is here. Please confirm once whether I am audible and visible or not. Then I'll proceed further in the lecture. Okay. Everything is perfect. Okay. Today we'll start with the last topic that we need to study. And yesterday we studied about Zener diode as voltage regulator. Okay. And short circuit test. And open circuit test. Okay. short circuit test and open circuit test. Apart from that, we also today will study about clamper circuit. What? Clamper circuit. Okay, so next thing is here, clamper circuit. How many of you guys know about clamper circuit? You already know about clamper circuit, please tell me. Clamper circuit, tell me, how many of you know about clamper circuit? Tell me. Tell me. How many of you guys know about clamper circuit? Tell me. Tell me, what do you mean by clamper circuit? Hmm? See. Clamper circuit. This is how circuit will behave. Now tell me pictorially what difference you find. This is V. This is V out. What is happening? Tell me. What is happening? Tell me. What is happening over here? Please tell me. Okay. DC level is being added. Correct. Absolutely correct. From here to here, what is happening? DC level is added. DC level is added. Fine. What I'm telling you, DC level is being added. Okay. Now, if I am saying that DC level is being added, so how I will commit that DC level is being added? Okay, very important thing. How we can say that DC level is being added? See, writing few basic points. Clamper circuit adds some DC level, adds some DC level to the input, okay. Clamper circuit adds some DC level to the input. What it happens? Clamper circuit adds some DC level to the input. Next thing, capacitor is the main clamping element. This is the main clamping element. Capacitor is the main clamping element. Capacitor is the device that we generally use for clamping. Okay, in clamper we use a very important device called as capacitor. Okay, diode is also used indeed, that's why we are studying, but along with diode capacitor is used. Okay, in case of that your clipper circuit there is no requirement of any diode or something like that. Fine. If positive DC level if positive DC level is added, if positive DC level is added, then if positive DC level is added, then we call it positive clamper circuit. Then we call it positive clamper circuit. If negative DC level is added, then we call it negative clamper circuit. So there are two type of clamper circuit. Okay, one is positive clamper circuit, one is negative clamper circuit. Clamper is not wave shaping circuit. Clamper is not wave shaping circuit. Okay, clamper is not the wave shaping circuit. Please pay attention to this point. Okay, clamper is not a wave shaping circuit. Fine. Then these are the points, just go through it. Okay, okay, great, superb. What is need of clamper circuit? See, if I talk about the need of clamper circuit, there is often requirement to add some positive DC level. Okay, like if you want to lift some signal or if you want to downgrade some signal, you need to add some DC level to it. Okay, so that is the cause of that is the use of clamper circuit. Okay, the most important thing why we study all these things. See, we have to operate very complicated integrated circuits. Okay, this is not the fact that what we are studying in analog circuit. For example, if you are trying to study about the analog circuit, I will tell you, uh, like we are studying basic. How many of you guys know about Apple? Okay, Apple is a mobile company. Okay, uh, it manufactures, assembles mobiles and many other devices like your laptop, earphones, many other things. Okay, so like what we are studying over here, we are studying very simple analog circuit. We are studying very simple analog circuit. In what sense we are studying analog circuit? I am giving you a circuit which has one diode. Okay, when we will study transistor, I will give you a circuit which has one transistor, two transistor. Worst case or toughest case is the three transistor. Okay, worst case or toughest case is what? Your three transistors. Okay, along with that, along with that, okay, along with that, I will say what? We will also give what? We will also give what? Op amp. In case of op amp, 2 3 4 circuits. But if you will come to the reality of the world of circuits, okay, what are practically required, you will find that Apple itself, a very small phone of this size, okay, a phone of this size, okay, this uses at least 1 2 billion transistors embedded in it. So inside that we have to go through very complex signal processing. We have to go through very complex signal processing. We have to play with signals. We should know every possible sort of mathematical tool, what we can do to a signal. Okay, so basic thing that I taught you was a clipping, how we can clip. Okay, how we can clip, that I told you. This is how we can clip. Okay, now I am teaching you how to clamp. Okay, and there are many more mathematical operations that we will be studying during operational amplifier, that integration, differentiation, logarithmic, addition, subtraction and whatnot. That's why to have command over signal we use what? That's why to have command over signal we use this clamper circuit. Okay, this is also one of the basic operations. So what I am doing is that positive. Bharat Kumar, my throat is really not well, so really sorry for that. Okay, somehow I am trying to take the class. Okay, positive clamper circuit. Okay, first circuit, I'll just to give you feel. Okay, what I'll do, just to give you feel, I'll explain you the working of clamper circuit. I'll explain you the working of clamper circuit. I'll explain you the working of clamper circuit. Fine. So when it comes to clamper circuit, positive clamper circuit, generally we use it with AC. It's not the fact that we should use it with AC, but yes, see. Okay, See, this is the circuit. This is capacitor. This is diode. This is RL. This is what? RL. Okay. Have you guys studied about this RC circuit in network? Have you finished your RC circuit? Tell me. In network, have you finished your RC circuit? Please tell. In network theory, have you finished your RC circuit? Okay. Network yet to start. No worries. In college first semester, you might have studied a bit of network. For a better understanding or better visualization, I am taking into account more than one cycles. Okay. I am taking into account more than one cycle. Fine. Okay. Okay, so this is the waveform. Fine. This is your Vin. This is your Vm. This is your minus Vm 0 T by 4 T 3 T by 4 and 2T, and there I'll write directly now 3T and all. Okay, now this is your V out. I'll make few levels. Like this. See, this is the circuit. RL multiplied by C. Okay, RL multiplied by C should be greater than time period. Should be not greater also. It should be very high than time period. It should be very high than time period. This is called as clamper circuit, clamper condition. This is your this is called as your clamper condition. This is called as your clamper condition. Fine. This is called as your clamper condition. Fine. This is called as your clamper condition. Now let's start with the working. I'm talking about the time period of this, na? Time period of this input signal. See, first thing that we need to do is about the uh, time frame 0 to t by 4. That is your positive half cycle only. That is your positive half cycle only. Okay. So I'm talking about 0 to t by 4. I'm talking about 0 to t by 4. Fine. If I'm saying 0 to t by 4, see, Vc 0 minus was equal to 0 volt. That is uncharged capacitor. This is equal to 0 volt. This is equal to 0 volt. Fine. Now what happens? Circuit starts operating. Your value will go up. I mean, input value will try to go up. Input value will try to go up. Fine. If input value tries to go up, what is going to happen? If input value tries to go up, a very basic simple thing will happen. That is what diode will try to be on. Diode will try to be on. Okay. And if this diode will try to be off because this is positive. See, first positive voltage, this will not take because it will try to maintain its voltage. That is property of capacitor. This is nothing but what? This is nothing but property of capacitor. So first reaction of diode will be of reverse bias, open circuit. So what will happen in this case? Diode will get reverse bias. So diode will be replaced by RR. So what will be time constant? What will be time constant of the circuit? Time constant of the circuit will be RTH multiplied by C, and this will be RR parallel with RL multiplied by C. Okay. So time constant high, capacitor will not be charged. So Vc becomes 0 volt. Okay. Vc becomes what? Vc becomes 0 volt. If capacitor voltage becomes 0 volt, then what will happen? Capacitor voltage becomes 0 volt, then what will happen? V out will be equal to V in. Okay, so this will continue till when V out will be equal to V in. We are talking about 0 to T by 4. This will continue till here. See, V out is equal to V in. This is equal to your T by 4. This is also equal to T by 4. This is also equal to what? This is also equal to T by 4. Fine. Okay. This is the case. After this, what will happen? Till, sir, isn't that T by 2? T by 2 is this one. Yes, sorry. This is T by 2 and this is your, wait. I did some basic mistake over here. This is your T. Got my point? Now it is correct. Sorry. Okay. Fine. Now what will happen? Till the time voltage is positive, this will also be positive. Till the time voltage is positive, this number is also going to be positive. This number is also going to be positive. Next, first time voltage will become negative. Okay, and as soon as possible voltage will become negative, what is going to happen? Voltage becomes negative, diode will become on. Okay, diode will become on. If a diode becomes on, diode will become short circuit, and if diode will become short circuit, I copied this one now. Sorry. Okay. Fine. So this is your V in. Sorry. This is your V out. V out will become 0 simply. V out will become what? V out will become 0. Okay. V out will become 0. Then after what will happen? V out becomes 0 volt. Fine. V out becomes what? V out becomes 0 volt. And capacitor gets charged. Why? Because time constant is 0 now. How it is 0, sir? Time constant, see, it will become RL multiplied by RL parallel with 0 multiplied by C. So time constant becomes what? 0. Means what? Immediate charging of capacitor. Immediate charging of capacitor. This will result into what? This will result into immediate charging of capacitor. Fine. Immediate charging of capacitor. Done. After this charging ends, okay, what will happen? This will happen this one. Output will become 0. Output will become what? Output will become 0. And then after, capacitor will get fully charged. If this capacitor gets fully charged, okay, then what will happen? This will be the polarity of capacitor when it gets charged. Okay, so after being charged, see, not here, here. What I'll be able to do, I'll be applying KVL over here. This will be minus V in minus V in minus Vm plus V out is equal to 0. So V out is equal to V in plus Vm. V out is equal to V in plus Vm. Fine. If V out is equal to, if V out is equal to V in plus Vm. If V out is equal to what? V out is equal to V in plus Vm. Okay. So how your output will behave? Please check how your output is going to behave. This is your output. Okay. Whatever is input, see, this is 0. This is Vm. This is 2 Vm. This is minus Vm. Okay. So this is 0. 0 plus Vm. Vm like this, like this, like this, like this. So like this. Okay. This is how it looks like. And this is 2 Vm. This is Vm. Wait, no. This shape has gone wrong. This is how your waveform will look like. This is how your waveform will look like. This is 2Vm, this is Vm, and this is like this. Okay, so this is called your clamper circuit. This is called your clamper circuit. Fine. Okay, so let me end this today. Tomorrow we'll start because there is one class over here. Fine. Tomorrow we'll continue.